Greetings all of you. My name is Teacher Junju Isaac. So I welcome you to my channel. Please subscribe and recommend it to other colleagues. So here we are looking at trigonometry subsection triple angle formula. So what is the identity of sine 3x, cos 3x and tan 3x? So we are going to prove them. They are given here. We need to show that sine 3x is equal to this, cos 3x is equal to that, and tan 3x is equal to this. So before you watch this video, please check question 5, the previous video, 4 and 5 of double angle before you come to triple angle. So for the case of the triple angle, we shall have to use a double angle somewhere. So let us see the first one, part A. We are going to prove this. So I'm going to write sine 3x as sine 2x plus x. Then from the compound angle formula, which we already know, if we expand this, it will give us sine 2x cos x, then plus sine x cos 2x. We covered this. Now when you come to this line, you see that now we have a double angle, but of course we have got rid of the triple angle. And when you look at the right hand side, there is nothing like double or triple angle. So far we have achieved a single angle here on cos and this cos, but there is still a double angle which you have to eliminate. So we know the identity for sine 2x, that is 2 sine x cos x, then times a cos, then you add the sine x. Now we have a cos 2x, but remember cos 2x is equal to cos squared x minus sine squared x. It is also the same as 1 minus 2 sine squared x. It is also the same as 2 cos squared x minus 1. So the best identity to use here is the one which is having only sine, this one here. So we leave around this which contain the cos, because we need to get a sine on the which is on the right hand side. So I will instead use this one here among the three. So I'll have to write 1 minus 2 sine squared x. So let us see what comes out after that. So this is going to be now 2 sine, and we have a cos squared x, then plus here sine times 1 is sine x, then minus 2 sine cubed x. Well, now there is a x here. We are lucky that we have single angle throughout, but now the problem is still on the cos here. We must get rid of this cos squared. Now we know from this identity cos squared x plus sine squared x equal to 1. So if I want to get a cos squared x in terms of sine, I'll get 1 minus sine squared x. So I'll come back here and I say that this is going to be 2 sine x times the cos squared. I take 1 minus sine squared x, then plus sine x minus 2 sine cubed x. Now another achievement that we have now eliminated the triple angle, the double angle, the cos. We are remain with sine throughout. So from that we just simplify and we see what we remain with. So let us expand this by removing the bracket. I'll get 2 sine x minus 2 sine cubed x, because this is sine and this is sine squared. So minus sine squared times the 2 sine, you get a minus 2 sine cubed. So plus sine x minus 2 sine cubed x. So let us see, we have a sine here and a sine here, 2 sine, and 1 sine gives us a 3 sine x. Then minus 2 sine cubed minus 2 sine cubed, that is minus 4 sine cubed x. And that part A is proved. So let us go to part B. So part B, we have a cos 3x equal to that. So again, I will write my cos 3x as 2x plus x, cos 2x plus x. And when you expand this from the compound angle formula, this will be cos 2x cos x, then minus sin 2x sin x. So there is a double angle here which we can now eliminate, and remember that cos 2x is the same as cos squared x, 2 cos squared x minus 1. So I'm using this because I need to have cos only. So I'll get 2 cos squared x minus 1 times cos x, then minus. Where we have sin 2x, it is going to be replaced with 2 sin x cos x, then times sin x here, which means sin x, and sin x gives us a sin squared x. Okay, so now from here let us expand this, and now you can see before even expand there is a sign which we don't want, and from the identity of sin squared x plus cos squared x equal to 1, it means that the sin squared x will be 1 minus cos squared x. So we shall get, this is going to be cos multiplied with this, giving us a 2 cos cubed x minus cos x, then minus 2. Where there is a sin squared, I'll put 1 minus cos squared x, then cos x. So this gives us a 2 cos cubed x minus cos x, then minus. Now there is a minus 2 and there is a cos out, so this is minus 2 cos times 1, you get minus which is a plus, not a plus, but it will be a minus 2 cos. Sorry, this is going to be minus 2 times 1, then times the cos, we get minus 2 cos x. Then we have a minus 2 cos times minus cos squared. Now this becomes a plus 2 cos cubed x. So now when you look at this cos cubed and another cos cubed, 2 cos cubed plus 2 cos cubed, you get a 4 cos cubed x, then minus 3 cos x. And when you look at what is needed, we have proved it. So left hand side is equal to the right hand side. Now let us go to part C. Now for part C, we have tan, which we can tan 3x, which can be written as tan 2x plus x, and this can be from the factor formula, compound formula. This is the same as tan 2x plus tan xc, then divided by 1 minus, we put a minus, don't forget that, up is a plus, down is a minus when we have a plus here. So it will be tan 2x, then tan x. Now we know that tan 2x, this double angle, is the same as 2 tan x over 1 minus tan squared x. So we shall need to but tan 2x is equal to this, so we need to replace it here. So we shall get 2 tan x, 2 tan x over 1 minus tan squared x, then plus tan x divided by 1 minus, then this is going to be 2 tan x, which is 2 tan squared x over 1 minus tan squared x. So this becomes, let us put everything under the same denominator, so the LCM here, I'm going to cross multiply and transpose this times this, then this times this, so we shall get 2 tan x then this and this, we shall get plus tan x. Let us have enough space. So this is going to be 2 tan x, and this will give us tan x times 1, we get a plus tan x, then tan x times negative tan squared x, we get minus tan cubed x over 1 minus tan squared x, then this all divided by, again we are going to cross multiply and transpose, so this will be 1 minus tan squared x, and the other one will be minus 2 tan squared x, then over 1 minus tan squared x. So what we can see, that this one will cancel, this cancel with that, we remain with this plus this is 3 tan x minus tan cubed, then over, now when you look at this, it is 1 minus tan squared minus 2 tan squared, which is 1 minus 3 tan squared x, which is required. Alright, so you can now conclude that the left hand side is equal to the right hand side. Thank you for watching. Let us meet in the next video, that is question 7. Again, we are going to look at the triple angle identity, how we use it to prove. We use the triple angle formula to prove several identities. Alright.